Hey guys, this video is going to go over 11.5, which is volumes of prisms and cylinders. This is something that is probably review for most of you, but we do need to go over it. So with that, let's start off with some vocab. So the volume is the number of cubic units. So it's cubic, so something to the third power, contained in the interior of a solid. So we are in three-dimensional space here. Cavalari's principle is a very, very important thing, but don't go and look it up and research it because it can be very, very complicated if you don't understand it. Your book mentions it, so we'll mention it, but you don't really need to do anything other than just know what it is. So Cavalari's principle, if two solids have the same height, and the same cross-section at every level, then you conclude that that also has the same volume. All right. A prism, guys, is a polyhedron, which we talked a little bit about, or a lot of it about, in section 4, where both bases, they have to be congruent and parallel. If they're not, it's not a prism. And the faces, as we learned, are rectangular. All right, a cylinder is, once again, it's a non-polyhedron, as we discussed in section 4, in which both bases are congruent. They are also parallel. And what makes it a cylinder is they are circles. Similar solids, two side links, they have the same ratio. Dealt with those before. And then density, for those of you in chemistry, you may have done this, the amount of mass that an object has in a given unit of volume. Some of you might know that the equation to find the density is density equals mass divided by volume. We'll do an example problem here in a minute with that. All right, so the volume of a prism is V equals big B times H. Well, the big B is not, well, it kind of is the base, but that's not it. The volume of a prism, I like to write it as it's the area of the base times the height. Now, when we think of height, we usually think straight up and down. Remember that the height doesn't have to be straight up and down. It can be side to side or slanted. The height is just the distance between the bases. Okay, it's not always straight up and down. All right, so let's do a couple of examples. All right, well here, this is a triangular prism. The reason it's triangular is because the base is this triangle right here. So triangular prism. Okay, now to find the volume of a prism, remember volume is the area of the base times the height. Okay, well, triangular prism, therefore the base is a triangle. So first thing we want to do is we want to find the area of the base. And that base is the triangle. Okay, so this right here, if I were to draw it out, it looks like this. Notice here's a right angle. I've kind of covered it up. This is the same as this, so this is 3. This is the same as this, so this is 4. We don't know that, but we don't need to. We know that the area of a triangle is 1/2 times the base times the height. So this is just going to be 1/2 times 3 times 4, which is 6. Okay, that's just the area of the base. Okay, so we can plug this 6 in for this. So the overall volume of this thing is the area of the base, which is 6, times the height. Remember, the height is the distance between the two bases. So here's a base on top, here's a base on bottom. The distance between them is 2. So our answer would be 12, and then don't forget your centimeters cubed. All right, let's do the next example. Well, here, guys, the base is a trapezoid. So this would be a trapezoidal prism. Okay, now the area of a trapezoid, so area of the base, which would be the area of the trapezoid, we can find that by 1/2 base 1 plus base 2 times the height. Okay, so if we're looking at this, my base 1 I can put right here, which is the same as this, which is 6. So 1/2, 6 plus my base 2 is here, the whole thing, which is 14, times my height, so the distance between the two bases, which is 3. Okay, so this is just 1/2 times 6 plus 14 is 20 times 3, which is 1/2 times 60, which is 15. No, 1/2 times 60 is 30. Sorry, guys. Whew. It's been a while. Okay, so that would be the area of this trapezoid, which is the base. So we put this 30 right here, up here. So if I want the volume of the trapezoidal prism, I'd have my volume equals, well, the area of the base is 30, times the height, which is the distance between the two bases, which is 5. So let me erase this. 30 times 5 is 150. And then don't forget your centimeters cubed. Here's your answer. All right, let's go to volume of a cylinder. Now, anytime we have something with circular bases, it makes our life a whole lot easier. Okay, so the volume of a cylinder is still, the reason your book puts this in prisms together, it's the same formula. Okay, so it's still the area of the base times the height. However, the area of the base will always be a circle, and therefore the area of the base will always be the same equation. So we can just replace this. The area of the base is pi r squared, that's the area of the circle, times the height. And once again, the height is the distance between the two bases. All right, so let's do an example. Okay, so the volume of this is going to be pi r squared. Well, it gives us our r. So pi times 9 squared times our height, which is 6. So this is just simplifies to 486 pi, and that would be feet cubed. All right, let's do one for B with it slanted, guys. Don't let it be slanted. Don't let that throw you off. The volume's still pi r squared. Notice the r is 4. Times the height. It wants a straight up and down height, which is 7. Guys, when we square this, we only square this 4. And just like over here, we're only squaring this 9. Okay, when we do all that, we get 112 pi centimeters cubed. And of course, if you wanted to get that as a decimal, you just put pi into your calculator. 112 times pi. All right. Example 3. Density equals mass over volume. This is definitely an equation you should know. Or if you don't know now, you should know it going forward. You will use it a lot in science. Pretty important. All right, so it says the diagram shows the dimensions of a standard gold bar at Fort Knox. Any of you guys don't know what Fort Knox is, you should research it. It's pretty intriguing. Gold has a density of 19.3 grams per cubic centimeters. So the density is 19.3 grams per centimeters cubed. Find the mass of the standard gold bar to the nearest gram. All right, well, when I'm looking this, I first note that this is in centimeters and each of these are in inches. Okay, so I want to convert each of these sides of the gold bars, I want to convert those inches to centimeters. So 1 inch is roughly 2.54 centimeters. So all I'm going to do is multiply each of these sides by 2.54. And when I do, I get 17.78. I get 9.2075. And I get 4.45. And these are all now in centimeters. These are in centimeters. Okay? So density equals mass over volume. Well, guys, I can find the volume of this, right? It's just the area of the base times height, or length times width times height. It's like a box, a rectangle, is the base. So the volume of this is 17.78 times 9.2075 times, I'm running out of room, so I'll put it down here, 4.45. And when I put that into my calculator, I get roughly 728.5, give or take, centimeters cubed. All right, so density equals mass over volume. Well, we have the density, we have the volume, we can find the mass. So if I plug it in, density equals mass over volume. My density is 19.3, so I'm going to plug that in for my D, equals my mass, which I don't know, over, I know my volume, 728.5. Now to solve for mass, all I do is multiply 728.5 on both sides. So I get my mass is roughly, that's big, or to the nearest gram. So I'm gonna just erase this, 14,060, and that would be in grams. So pretty heavy. All right, one more example. I guess there's two more examples. All right, we've done this in 2 dimensions. Now we're gonna do it in 3 dimensions. So cylinder A and cylinder B are similar, okay? Meaning that the ratios of their sides are proportionate. So to find the scale factor in 1 dimension, well, we have 3 over 6. 3 over 6, which just reduces to 1/2. This is the scale factor in 1 dimension, okay? So when we went to area, which is 2 dimension, if you remember from chapter 8, we squared this. So to go to the 3rd dimension, wouldn't it make sense to cube it? So scale factor in 3 dimension would be the scale factor in 1 dimension, and that's to the 3rd. Okay, so remember, this is the same thing as 1 to the 3rd over 2 to the 3rd. 1 to the 3rd is just 1. 2 to the 3rd is 8. Okay, in other words, the volume of this is 8 times bigger than the volume of the smaller one. So if it's 8 times bigger, all we'd have to do is do 45 pi, 8 times bigger, times it by 8. And when we do that, we'd get roughly 360 pi, and that's centimeters cubed. And if you want that as a decimal, just put it in your calculator. All right, we'll do a composite solid, and then we will be done. All right, so this thing, it's kind of hard to see. We have this triangular prism where the front and the back are the base. Here's my base, okay? And then we have this rectangular prism through it that we're like removing it, okay? We're taking it out of the hole. So the volume of the triangular prism would be well, the composite solid. So we have the volume of triangular prism, and then we're removing the volume of the rectangular prism, so it would be minus volume of rectangular prism. All right, so I'm gonna do this as like two separate problems right now. So let's do the triangular prism first. Okay, so we need, the volume is gonna be area of the base times the height. Okay, so the height would be the space between the two bases. Well, the base is front. And notice by these tick marks, there's two tick marks on each side. So this is an equilateral triangle. Okay, so this is 10, 10, and 10. So if I were to just draw it, well, first let's find the area of the base. The base looks something like this. 10, 10, 10. Okay, to find the area, we want 1/2 base times height. Okay, so the area is 1/2 base times height. Well, the base is 10. Now the height, we don't know. Okay, so to find that height, when we draw it, this is 5, this is 5. We want to find this. Well, we have a right triangle now. So can we just do 5 squared plus 10 squared equals h squared? So 5 squared is 25, 10 squared is 100, so 125 equals h squared. So we would get roughly 11.2. Roughly 11.2 equals h. Okay, so this is 11.2. Okay, so the area of the base then, guys, when we plug it in, 1/2 10 times 11.2, this is roughly 56, but that's just the area of the base. So we would plug that in there. So the volume, let's get back to it, is the area of the base, which is 56, times the height. Remember, the height would be the distance between the two bases. Well, here's the other base back here. So the distance between those would be this 6. So 56 times 6 is roughly 336. All right, now let's find the volume of the rectangular prism, which is a lot easier. So it's just area of the base times height. Well, the area of the base, guys, is a rectangle. So it's just a length times width times height. We'll notice this 3, this is also a square. So it'd be 3 by 3 by, how long is it? Well, that's the 6. So this is just 9 times 6, which is 54. Okay, so now I go back to what I had before, the volume of the prism, of the triangular prism minus the volume of the rectangular prism. Well, this is just 336 minus 54, which is approximately, remember this number at least is approximate, 282 feet. All right, hope this helps. Homework will be on big ideas, and I'll talk at you guys later.